DeviceNet came before EtherNet/IP. Back in the 1990s, this is how Alan Bradley connected the small stuff on a machine. Sensors, drives, push buttons, remote I/O blocks, all wired back to the PLC over one shared cable. Newer networks have taken over since, but DeviceNet is still sitting in plenty of plants today, running fine. So what is DeviceNet really? In this video, I will explain what it actually is. A device-level field bus, built from the CIP protocol running over a CAN bus. I will show you the cable that carries power and data together, how nodes are addressed, and where it still fits versus EtherNet/IP. Let us start with where it lives. Quick note before we dig in. This is from PLC Simulator, where you can practice PLC networking and the rest of this video free, right in your browser. No install, no hardware. The link is in the description. Click the link in the description to try it free. Now, back to DeviceNet. Start with where DeviceNet lives. Is a device-level field bus. That phrase matters. Device level means the network down at the bottom of a machine among the field devices, not the plant backbone up top. Its whole job is to connect the small stuff. Photo eyes, proximity sensors, push-button stations, drives, remote I/O blocks. Normally, each of those needs its own home-run wire back to the PLC. That is a lot of copper and a lot of terminals. DeviceNet replaces all of it with one shared cable. Every device hangs off the same trunk, and the PLC talks to each one by address. Less wire, fewer terminals, faster to commission. That is the pitch, and it is why it caught on. Now the two halves that make it work. DeviceNet is the CIP protocol running on top of a CAN bus. CAN is the rugged serial bus invented for cars. DeviceNet borrows it for the physical and data link layers. Here is the clever part, the cable. A DeviceNet trunk is a single 4-wire cable. It carries 24-volt DC power and the CAN data signal together in the same jacket. Drop lines tap off the trunk to each node. So one cable powers the devices and carries their data at the same time. You terminate both far ends of the trunk with a 121 ohm resistor to stop reflections, exactly like any other CAN bus. Power and data, one cable terminated at each end. Every device on the bus needs an address. On DeviceNet, that address is called a MAC ID. It runs from 0 to 63. 64 addresses, so a single segment supports up to 64 nodes. You set the MAC ID on each device, usually with little switches or in software, and no two nodes can share one. Then you pick a baud rate for the whole bus. The choices are 125, 250, or 500 kilobits per second. And there is a trade-off. The faster the baud rate, the shorter the cable you are allowed to run. 500 is quick, but stays short. 125 is slower, but reaches furthest. Same idea as any field bus. Speed costs you distance. Here is the part that ties it all together. DeviceNet is part of the CIP family. CIP is the Common Industrial Protocol, a shared object model for industrial networks. 3 networks use it: ControlNet, EtherNet/IP, and DeviceNet. They share the same objects and services. What differs is the wire underneath. EtherNet/IP runs CIP over standard Ethernet. ControlNet runs it over its own coax bus. DeviceNet runs it over CAN. Same objects, different wire. So once you understand CIP on one of them, you mostly understand all 3. I have a separate video on EtherNet/IP and a wider one on field buses in general, both linked below. So where does DeviceNet fit today? On legacy lines, you will still meet it. Sensors, drives, and I/O blocks hanging off a DeviceNet trunk, doing their job year after year. If it works, there is rarely a reason to rip it out. But on new builds, the story has changed. Most of that device-level traffic has migrated to EtherNet/IP. The reason is simple. One CIP network can now run from the field device all the way up to the plant floor. No gateway, no second protocol. So think of DeviceNet as the device-level network that EtherNet/IP grew up to replace. Know both because you will service the old and build the new. So here's what to walk away with. DeviceNet is a device-level field bus. It is the CIP protocol running over a CAN bus. One 4-wire cable carries power and data together, dropped to nodes addressed by MAC ID 0 to 63. It is part of the CIP family with ControlNet and EtherNet/IP. Same objects, different wire. And on new machines, EtherNet/IP is taking its place. Get that, and every old Allen Bradley network stops being a mystery. Now, go make it concrete. If you want to practice PLC networking hands-on, click the link in the description to start free at plcsimulationsoftware.com. No hardware, no install. Subscribe. New video every Tuesday. See you in the next one.